In this video, let's talk about conic sections. Before discussing conic sections in depth, let's first discuss what cone is and how it produces. This vertical line is the vertical axis of the cone, while this one is cone's generator. Let's try to rotate the generator around the vertical axis while the angle between the generator and vertical axis remains constant. Let's now rotate the generator around the vertical axis somehow like this. As a result, the right circular cone is generated, which was later referred to as cone. This is the base of the cone and its lateral surface is referred to as cone's nape. In a double nape right circular cone, this part is upper nape of the cone, while this part is lower nape of the cone. The point joining both the napes of the cone is its vertex. Having given a brief overview of cone, let's now turn our attentions to the conic sections. When we take the intersection of plane with a cone, we obtain a section that is called conic section. Before getting into the specifics of conic sections, let's first take a look at a key perspectives that is crucial to comprehending the various conic sections. So here, the angle between the plane and cone is very important part to produce different conic sections, that is different cross sections of cone. Here alpha is the angle between the vertical axis and the generator, while beta is the angle formed after the intersection of the plane with the vertical axis of the cone. Here it is beta. When the plane cuts the nape, whether it is lower nape or upper nape of the cone, different types of conic sections can be formed depending upon this angle called beta. Well, now I will demonstrate how we may create different cross sections from the intersection of the plane and the cone. If the angle between the plane and the vertex, that is beta, is 90 degrees, then we get a circle. Right now, the plane is at the vertex of the cone, and here the intersection between the plane and the cone is a point that is vertex. Now, if I move the plane downward or upward, you can see the intersection of the plane and the cone is circle. So here the cross section we get is circle. You can see right now the angle between the plane and the vertical axis is 90 degrees. If I change this angle, that is angle between the plane and vertical axis, let's take it between alpha and 90 degrees, where alpha is the angle between the vertical axis and the generator. Let's change the slope of the plane just like this. Well, now I am moving this plane to see a clear picture of the cross section. Let I am moving it upward. You can clearly see that the cross section is an ellipse. Well, now I want to get a cross section that is called parabola. So for parabola, the angle alpha and beta should be same. Let's get this angle. I am changing the slope of the plane to get alpha is equal to beta. So that is the perfect angle. So you can see here the cross section from different angles. That is a parabola. The important thing that you can see here, to get parabola, the slope of the generator, that is generator, and the plane is same. So when alpha is equal to beta, it means the slope of the plane and the generator is same. Right, if here I take the angle beta equal to 0 or between 0 and alpha, then what would be the cross section of the cone? Let's get the angle 0. Angle 0 means the plane should be vertical. Let's get the plane vertical. This is vertical plane. So you can see here, this is very understandable and transparent that the cross section here is hyperbola. So if beta is 0 or between 0 and alpha, then the cross section would be hyperbola. I hope you enjoyed and learned from this video. Let's have another look on the conics. Thanks for watching.